All right, so today in our unit exponents, we're looking at the power of a power law or the power of a power property or the power of a power rule. So just going through all these rules that we've looked at so far, we are here, power of a power rule. Okay, so when we are solving any question that has two or more exponents and a set of brackets on a number or a letter, we are going to multiply the exponents. We're going to keep the same base, and that's called the power of a power property. So here we can see we had x as the base to the power of a and then to the power of b. We multiply the exponents, so it becomes x to the power of ab. Okay, let's take a look at our first example. We have 8 to the power of 5 to the power of 3. So we're going to multiply these exponents. It's going to become 8 to the power of 5 times 3, which becomes 8 to the power of 15. All right, this of course can be further put into the standard form because we can put in our calculator 8 to the power of 15, but we are going to leave it in exponential form. This would be a very large number. Okay, so next we have x to the power of 7 to the power of 4, so it becomes x to the power of 7 times 4, which is x to the power of 28. All right, next, very important to pay attention to brackets. We also have two variables in this example. We have a and b. Those are our bases. So we have two bases. Remember that this exponent on the outside of the bracket is applying to everything inside the bracket. All right, so this is going to become a to the power of 3 times 4 and b to the power of 2 times 4. So that becomes a to the power of 12 and b to the power of 8. All right, so for this next example, again, remember that this exponent of 5 will apply to everything inside the bracket. So this 7 basically has an exponent of 1. So we're going to have 7 to the power of 1 times 5, x to the power of 3 times 5, and then y to the power, and that is a negative 4 there, so it's y to the power of negative 4 times 5. All right, so that gives us 7 to the power of 5, x to the power of 15, and y to the power of negative 20. The next example we have, again, it is a fraction inside the bracket, but this exponent 3 is going to apply to everything inside that bracket. All right, so this will become 8 to the power of 1 times 3, x to the power of 5 times 3, y to the power of 6 times 3, and then it's z to the power of 4 times 3. All right, so that becomes 8 to the power of 3, x to the power of 15, y to the power of 18, and then z to the power of 12. All right, and then double check to see if there's anything more we can simplify here, and we cannot, so we are going to leave it as is. All right, so for these examples that you guys just tried, here, this becomes 3 to the power of 2 times 6, so it'll become 3 to the power of 12. Here, the base is y, and it's negative 6 times negative 3, so y to the power of 18. All right, here everything inside the bracket has the exponent of 4, so that means it's 3 to the power of 4, a to the power of 2 times 4, which is 8, and then b to the power of 2 times 4, which is 8. And the last one here, just remember everything inside the bracket has the exponent of 5. So that means it's 3 to the power of 5, then a to the power of 2 times 5, which is 10, b to the power of 3 times 5, which is 15, and all of that is over c to the power of 4 times 5, which is c to the power of 20. Okay, and then we cannot reduce any further, so we leave that as is. Okay, so for this first one, we do end up with x to the power of negative 2 times 3 times 4, because it's power of a power of a power. So negative 2 times 3 times 4. And then for the y, again, it's a power of a power of a power. So 5 times 2 times 4. All right, so that gives me x to the power of negative 24, and then y to the power of 40. Okay, so the last example we have here, the first step we'll do is we'll use the product law for this first part of the expression. So a to the power of 2 to the power of 3, so 2 times 3, that gives me a to the power of 6. And then we have b to the power of 2 to the power of 3, so 2 times 3, that gives me b to the power of 6. Then we have, it's being multiplied, so we have a to the power of 4, b to the power of negative 5. So we can further simplify this now using the product law, because all of these are being multiplied together. So we have a to the power of 6 and a to the power of 4. We're going to use our product law, which states that we would add the exponents. So this becomes a to the power of 6 plus 4, and then b to the power, so here's a b, and here's our b, is 6 plus negative 5. 6 plus negative 5. All right, so that would become a to the power of 10, and b to the power of 1, or just, we can just leave it as b.